So I have a challenge to start with. So hold on. I know we're... Hey, once you know what you're doing, it'll probably be easier. I want you to do something while everyone's getting stuff out before we check homework. So yesterday, where we ended our notes, we had started writing something about rock, paper, scissors. Right? We had started writing something about rock, paper, scissors. We started setting up like a little table. It's on my desk. Here I am looking for it, and it's sitting on my desk. Man, I'm a little not organized today. I should fix that. So, you did not set up this table yet, but if I relate what we did do yesterday, this table, I could actually make this table differently and make Chris's coin and Rachel's coin be the two different axes of the table. So I want you to see if you can figure out how you can use two different colors to fill in a rock, paper, scissors table. We're going to say that me and Mr. Smith are playing rock, paper, scissors against each other. Me and Mr. Smith. So we'd probably set it up like this, right? Draw all these divisions. But then see if you can figure out, and this is where we're going to use colored pencils. Notice that I'm using blue and green. And actually, I may want to use like blue and pink or something a bit more obviously a different color. So I might switch these to pink to make it obvious. So I'll get you started and give you a little hint. In this column, it would be every time that I throw a rock. Right? So this would get filled in with rocks all the way down. I want you to see if you can figure out how to fill in the rest of that table. And we'll circle back to this. So if you're not working on this, you should be getting out what you need to get out. I need to pass some stuff back, which is why I'm trying to have you guys work for a couple minutes. Yeah, I got a huge stack. And then I might actually move it. We'll talk to each other about how are you going to set it up. I bet you one of you remembers it. There's four. This is why I moved things around. No, I mean people who are alone. Independent islands, I should say. Oops, excuse me. I had to get a little creative, though, with removing that shelf. I had to fight gravity. I love that some people are labeling their table with people who are at their groups. Right? So, like, Franco's over there saying it's going to be Franco versus Layla on his table. You can set it up however you want. You can do Smith and Hudson. I think, guys, you need out your homework. So I'm just doing this to kill time while we pass out papers, but you need out your homework. 522 is due today, if you haven't turned it in yet. Man, it's like the front row that people don't sit in. I'm about to make my group of boys move up and be in the front row desk. Those are like the expensive seats. Oh man, my friend had their key fob hacked last night. Have you heard about that becoming a thing? No. They use like a scanner type thing to scan the frequency from your key fob, and they can just unlock your car. So yeah, if you keep your keys close to your door, don't. Like try to keep them kind of in the middle of your house.
Yeah, my car doesn't have a key fob.
There you go. See, that's the best option. My problem is my spare key is close to the door. All right, so real quick, we'll look at this, and then let's check homework first. Might as well check homework before we get into the new stuff. So if you have questions, like we talked about yesterday, it is your job to ask me those questions. So 522 is due today, so I will still take questions from 522. But answers, we looked at those answers yesterday. I can go back and look at those, but like, if you need to check the answer, you probably just want me to go over the problem. So 523, that's what I'm looking at right here. Now, if you couldn't answer these independent-dependent questions, that's okay. We're going to talk about that today. But if you already did the homework. So do you guys want me to go back and show 522 again? Or are we good? Like, I need some feedback from you guys. Kylie? Yeah, so actually, this one was a big issue, and I'm really glad that you asked about this. Everybody look at the back of 522. I was really hoping somebody would ask about that. So actually, Kylie, see me after class. I got a piece of candy with your name on it. When we look at number 42, so guys, as Miss Martin walks around, what she should be able to see, and not really her job to check this, but she should see everyone looking at the back of this paper with the graph on it. Now, we talked briefly about before we start graphing, we should look at what points we're going to have to graph and make some decisions based off those. But I think one of the issues getting some of us is we're forgetting a point is in X, Y order. So you might want to write that on your paper, that any point we're talking about is in X, Y order. And the X-axis is the horizontal axis. The Y-axis is our vertical axis. Any questions on what I've said so far? I'm going to try to color code this, I guess, because I already highlighted all these pink. So -3, 2. What that means is the X should be -3. So I go left, right, because left is the negatives. And guys, some of us made the negatives go up to the right. We're not allowed to do that. We have to start at the origin, and negatives are always on the left. So negatives are on the left and down. Positives are to the right or up, right, depending on X or Y or whatever. So you could make little notes to yourself to remember this is negative X's. This down here is negative Y's. Positive Y's. Positive X's. So -3, +2 would be right here. Questions on finding -3, +2. I go left 3, up 2. -8, +2 has the same Y value, but a different X value, so we're going to have to go left 8 instead of just going left 3. So 3, I know this was 3, 4, 5, 6, 7, 8, and then still up that +2. Sorry that my blue and my green kind of look the same under the camera. We'll switch to, let's go like lavender. -10, +8. So now I got to go even further out to the left to -10. And if you didn't give yourself enough space, you might have ran off the graph and realized, oh crap, I need a lot of space up in this quadrant. What's quad mean? 4. The graph is broken into 4 pieces. We call them quadrants. So -10 would be way out here. And then up to +8. 3, 4, 5, 6, 7, 8. Ooh, I barely gave myself enough space to go up this high. And then -5, +8. I don't know, lime green. Oh, orange. I don't use orange enough. -5, +8. So I only go left 5 now, but I go up that same 8. And now we can connect them together. And a couple of you guys that I helped do this problem, I told you that coloring or doing your shape in highlighter sometimes really helps, especially because my graph lines are a little bit thick here, a little bit darker than just your graph paper. And I reminded you yesterday that area of a parallelogram is the base. How long is this base? 1, 2, 3, 4, 5. Times height, which is the vertical height, guys. Literally, we draw a line straight from the bottom to the top, which is a height of 6. And what's 5 times 6? That's how we get 30. Questions? We haven't done a ton of graphing yet, so I don't expect you to have this mastered. But I expect you to ask questions when it doesn't make sense. Negatives have to go left on the X or down on the Y. If you made your negatives go up to the right, you just kind of essentially like flipped your graph over, which you're not really allowed to do. All right, so that was 42. They have it looking like this, but I gave you a graph space to do it on, so yours should be on that graph space. Eve?
You know, it already shows you this thing, but I'll do it all slow.
39? Aha. So, for C and D, D is really just you telling me how you thought through it. So D, there's no real right answer. You just write to me like kind of what you thought about. Did you like Google prime numbers? Did you like, stuff like that. So honestly, I expect a lot of people to say looked up prime numbers because we don't necessarily have prime numbers memorized. But in C, to figure out the probability of being prime or 1, I'm going to look up prime numbers. So literally, that's what I'm doing real quick. I find my prime number chart, and we're talking between 1 and 20, right? So I count 1, 2, 3, 4, 5, 6, 7, 8, but then also the number 1, and that's how I get 9 out of 20, because there are 8 primes, and then 1 more since we add the 1. We can do questions for maybe a couple more minutes, but then I got a lesson I got to teach. Guys, we got math lunch and extensions and AO all for this purpose also. This can't be your only time that you ask questions. It's like Eve pretty much comes to math lunch every day. So I will take questions from Eve all day long because she comes to math lunch and puts in that extra effort. But some of you need to put in some extra effort. So Eve, thank you so much for asking questions. You asked really good questions. All of you guys that actually ask questions, normally ask really good questions. Some of you just have to start asking questions. Is anyone actually done with 523 that they want to see, or should we just jump into the lesson? I mean, it's not due today, so do you have a specific question you want to check? Because otherwise I might save time and move on. If you're asking about 49, we're going to talk about that today in class. 50? I don't remember what that question is, but I'll flip to it here. We're going to talk about that today in class also. So it's probably easiest if we just move on. All right, so let's talk about our lesson stuff. Rock, paper, scissors from yesterday. We want to analyze, is this fair? So in this table, go ahead and flip back to this table. These are all of my rock. So what should I put down the middle column? All my papers. Paper. And down the furthest column, my scissors. Now I'm playing against Mr. Smith, and he can also throw rock or paper or scissors no matter what I threw. So Mr. Smith's rocks, rock, right? His go across the top instead of going down. his papers go across the middle, and his scissors go across the bottom. Anyone have questions about this table showing me and Mr. Smith's rock, paper, scissors results? Now we need to go through and see who wins. So, I used to have a blue highlighter. We'll do pink first, and then I'll go see if I can get a blue highlighter. Go through and color code. Like, if I look here at rock and paper, who wins, rock or paper? Paper. So Mr. Smith would win that box. I'm going to color code that like pink. Smith would win. Go through and figure out who wins in each of those situations. You guys remember, I have highlighters to borrow up here. I think blue is just not very common, so I'm going to steal the last blue one. But if you need to borrow highlighters or colored pencils or anything, it's all up front, dudes. So wait, if Smith won with paper versus rock, I could also win if I had paper versus his rock. Right? So I would win this one since I had paper against his rock. What about rock, rock? Who wins there? Nobody. We tie. Right? Paper, paper? We tie. Scissors, scissors? We tie. Where else would blue win? Can anyone volunteer to tell me where else I would win? You? Paper and scissors. So you mean like here? Because my scissors would cut Smith's paper. My scissors cut Smith's paper. But also, other way around, if Smith threw scissors and I threw paper, Smith wins, right? Is this making sense how we're color coding this table? Smith is pink, right? Smith is pink. I'm blue. We'll say Mr. Smith is pink because his youngest child is a daughter. Although I've heard Elaine likes to play with guns just like the boys, so she was a fairy with a gun. Rock, scissors. If I throw rock and Smith throws scissors, who wins here? I win, right? My rock smashes his scissors. What about that top right box? Smith would win, right? What is my overall chance of winning here? Actually, I should probably start using cards. Eli, what do you think? What's my overall chance of winning here? Sure. Yeah. You're always good to pass. Monda's on a different schedule.
No, you didn't. He was trying to say the answer.
Oh, what? Who? Go ahead.
I was trying to say, your chance of winning is practically 50%. Because also, because Smith has 3 and you have 2.
Yeah, be careful, though. Are the only two options me winning or Smith winning? So this messes with things, right? These ties. So we kind of got to talk about that. When you play rock, paper, scissors, what's your probability of ending in a tie? 1/3, like 3 out of 9, or we can reduce that to 1 out of 3. I know, which is why I often say fractions are better than decimals. The probability that I win, 3/9. The probability that Smith wins, so because Smith and I have an even chance of winning, Vanessa, do we call this a fair game or an unfair game? It's fair, because we have an equal chance of winning. Rock, paper, scissors, we would consider a fair game. Questions? No, because we're going to keep using them. Thank you for asking. All right, we would consider rock, paper, scissors fair. So, if we played rock, paper, scissors 12 times, either what you wrote on your paper, you versus whoever, or me versus Smith, how many times do you think I would win? How many times? You're going to talk with your team for a minute. Will Smith dies at the end of the movie. How many times would I win? How many times would Smith win? And how many times would you think we would tie? Chat with your team real quick. Careful using all the same color, because that looks a little bit. Borrow highlighters from me, dude. Yeah, maybe they should have grabbed 3 colors, actually. 3 might be better. Mia, if played 12 times, how many times would we expect to tie? Aiden, if played 12 times, how many times would we expect for me to win? And Antonella, how many times would we expect Smith to win? Yeah, each of these is gonna be 4. Because, guys, we said they're all actually a 1/3 chance. So we do 12 times 1/3. Sorry, you can't see that very well. And that would predict that I'm going to have 4 wins, 4 losses, and 4 ties, right? Each of these things will happen 1/3 of the time, which here is 4. Questions? It's really quiet. We're in here till 11:30, by the way. I'm saying that out loud so I can remember. All right. So, draw a squiggly line, or if you're like me, you might need a fresh sheet of paper at this point. So, do whatever you need to do. Fresh sheet of paper, draw a squiggly line across, whichever works. All right. So, a question you should have seen on your homework that would have made you, like, scratch your head if you didn't, like, do some research about this on your own. Or, I mean, you might be able to infer, right? Like, kind of use context clues. Or what, John? Oh, man! Or if you look at the math notes box that is on the top of your homework. What homework are you talking about, John? 523. Oh, you mean the homework that asks you these questions? Man, who planned this out? Maybe some guy who's done this a couple times. Independent and dependent events. If you don't want to write down the definitions, we can look here and highlight these. Independent. Guys, so if you don't have a highlighter, run up and grab one. Like, I got a jar full of them up there. The outcome of one event does not affect affect, right, versus effect. Affect versus effect. Independent is like if I flip a coin and roll a die. Does my coin flip relate to my dice roll? No. But if I Well, I don't want to show it because we're on the video, but if I have already pulled this many cards out of our deck, and those of you who haven't been drawn are in this pile, and I pull another person and another person, your chance of getting pulled, is that independent or dependent? Dependent. Because dependent, and I would maybe use a different color if I was you. Yeah, because I don't put them back, right? Dependent says the outcome of the first event affects the other event. Can anyone remember a question? We talked about one of these things in class the other day with our full decks of cards. We had this question in class. And I remember we talked about a dependent event. What is my chance of drawing an ace? And a whole deck of cards, fair deck of cards, what's my chance of drawing an ace? Aiden? 4 out of 52. So I shuffle up my cards, and this is going to be different than what we talked about last time. And I draw a card. It's a 5. I put it on the table. What's my chance of drawing an ace now? Eli? 4 out of 51, which means now event 2 changed, right? The probability changed. That's dependent, right? So dependent, things change from event 1 to event 2. If you would like to write down your own definitions, you may, but it's on your paper, right? I'm trying to make your life easier. It's on your paper, and I know we don't have tons of time when I get into this chapter. Look over these situations and talk to your team about, do you think they're independent or dependent? Dependent means it does change, right? Dependent does change. Vincent, what can I help you with, dude? Yep, I didn't have room extras. Yep. Hey, like, try to stop losing your patience, right? Man, I don't think I have a quarter. It won't be totally valid. I know, I have pennies. Because I think somebody's a lot less likely to steal my pennies than they would be to steal quarters from me. Oh, I do! Somebody left money in here yesterday. I forgot. They left like 35 cents. You got 30 seconds and then we're doing random cards. There's probability involved in that. Ha-cha-cha. All right, Marina, if I have a quarter and I flip it and I get heads and then I flip it again, is that independent or dependent? Sorry, say it again. Independent. So we can label this with like an I because does the first heads impact the second one? No. Right? The first one does not impact the second one. I can't hold on to stuff today. Kylie, if you have a deck of cards, different deck, and you choose a jack, or you're looking to choose a jack, does it say? Yeah, it says choose a jack. So let's see if I can find one real fast. Of course I won't be able to. You get a jack. You with me, Kylie? You keep it out. You're like, oh, I like that jack. And now you got to pick another card. Independent or dependent? Dependent, because things changed. We kept the card out. Okay. I'll show you guys my magic trick. No. Which, first off, that was a jack that just flew out of the deck, which was kind of cool because that was what we were talking about. I think I probably have shown you, but if we have time at the end of class, I'll show you it's a very simple magic trick. Picking, ooh, I gotta say who I'm talking to. Vincent! Picking a blue marble from a bag of marbles, putting it back, and then picking another blue marble. What do you think? Why is it independent?
Because if you take it out and then put it back in, it's just like you're not really doing anything.
Yeah, it's like a reset, right? When you put it back in, you restart everything. And, Farah, what about if I have my number cube, right? Because we don't like to say the word die, so they often say number cube. Rolling a 6, another 6, and another 6. Are those independent or dependent? Independent, because my die resets every time, right? I can't, not replace my die, right? I can't, take the 6 off of the die. That doesn't make sense. So what I get on one die does not impact anything. Make sense? Cool. Questions? Okay. More tables. Alright, so here's a new game. Alright? So, we're going to create a strategy to play a board game based on our predictions of likely outcomes. We're going to place 10 O's on a number line. Now, if you paid attention, you might have some strategy here. Then, your teacher will roll 2 number cubes. I might let you guys do it. And add the resulting numbers. As I roll the number cubes and call out each sum, you will cross out one of your O's. What you want to do is cross out all of your O's. So, let's, on our paper, I did not want to print this because I didn't want to use another resource or another printer paper when we don't need to. We're going to label this 10 O's. 10 O's. And you could really draw whatever. Circles are just quicker to draw. What's the lowest outcome when you roll 2 dice? Ooh, careful. 2, 3, 4, 5. And you can use your graph paper to space this out nicely if you want. It was almost spaced out nice. So decide, where are you going to put your 10 O's? If you think back to what we talked about before, it might help. If you think about this paper or pull out this paper, it might help. Or we will have a little learning lesson here that we should have paid better attention. But it's all right. This is not a test, right? This is just more activities about this. I kind of want to do it, but I sort of want to do it in secret. So I think I'm going to do it on my paper. Oh yeah, you can put as many O's on a number as you want. I mean, so really just circles, right? Because they're fast to draw, but you could do squares or whatever you want. So, for example, if I think that a 2 is going to happen, I could put a circle over 2. But if I think that 4 has a better chance of happening, I could put 2 circles over 4 because I'll need to cross them out twice. Right? So put your circles wherever you think they're likely to be crossed out. What? Can you put all of them on the same one? I don't know if that's a good idea, but you can. I mean, I didn't say you can't. I don't know if it's a great idea, but. Now, as much as I love rolling dice, because actually I think the next project I might make for myself is a dice tower, which is like a thing you drop dice into and it shakes them up for you. But as much as I love rolling dice, what? Ah, I see. That's a little bright. So here's how we're going to do this. Because I want to show you guys we can change the dice color on here. I don't like that the circles are like messed up. Whatever, I guess. It's not really whatever to me. It bothers me.
Yeah.
We are going to put X's above. This isn't going to work very well. We're going to put X's above whatever result we get. So even if you don't have a circle, you're going to put an X above the result. Okay, so I'll start with you. And we'll probably have to do a little jumping back and forth on my tabs, but we'll see if this works. All right, so we said this doesn't count because it's the first one, right? So we got to roll and roll. 3 and 2, what'd we get? 5, so put an X over your 5.
Wait, what if we have?
If you have a circle, put an X on one of your circles, like cross out one of your circles. Right? I did not put my circles up here because I didn't want to influence you, but especially since I'm using the computer, I'm hopeful that what I think should happen will happen. What are you opening? Google? Okay, so roll number 2. 3 and 6, 9, right? So go ahead and put an X over a 9. Are we catching on to what's going on? Can I speed up a scotch? Speed up a scotch. Click, click. 3 and 6, another 9. Roll, roll. 1 and 1. Oh, snake eyes. Roll, roll. 5 and 5. 10. We ready? You guys, your X's should match mine, but if you had circles, you should be crossing them out, right? Roll, roll. 5 and 4. 9. 9 seems popular. What? Hey, what sort of graph is this starting to look like? Similar to a bar graph, but there was another name. It looks like a dot plot, right? Or a dot graph where you put dots at the results that you get. So we're essentially making a dot plot here, guys. Roll, roll. 4 and 1. 5. Can anyone tell me something that they think is curious right now? Anyone want to volunteer for like, what is going on? Lucas?
7 hasn't been called yet, because 7 has dice is red. 7, the number 7 has 6 ways it can possibly be rolled, and it hasn't been rolled yet.
The glorious game of Catan taught us that dice rolls are not equal to each other. And this seems a little weird. Now, I love when 7th graders throw out, it's rigged. Yes, because this publicly accessible website owned by a textbook company is trying to mess with you. No, what did anyone remember the law I talked about that said probability won't happen immediately? Yeah, it was called the law of large numbers. So even though 7 hasn't happened yet, we know 7 should happen, so let's keep going. 2 and 4. 6, so we got our first 6. Roll, roll. 1 and 4. We got another 5. Roll, roll. 1 and 6. Hey, there's our first 7. That's the wrong thing. Roll, roll. 2 and 5. Another 7. There we go. The 7s are starting to catch up now, because the more that we do this, the probability should equalize out like it should. Roll, roll. 1 and 3. 4. We haven't had a 4 yet, so. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I know you guys only had 10 circles, but we got a couple minutes left. You want to keep going?
Are we supposed to learn to make off the
3 and 6. Another 9. Let me double check if there's something you don't know how to do yet. I mean, probably, because, I'm not a very good teacher. 524? I think you're... Oh, that's Math 8. Oh, friends. I goofed up. I put the Math 8 homework in the Math 7 slot. Check your homework. Does the top of it say CC2 or CC3?
It says CC3. I CC3. It says CC3.
I messed up.
I'm
I yeah, so if you did 524 ahead of time, I goofed up. I gave you guys the Math 8 homework by accident. Well, that's what CC3 means. So, here's the deal. Yo, rip 524 out of that packet, because it says CC3. And bring them up here and make a pile on my little table up here. Not really, but I am glad that we caught the mistake.
Oh wait, I have an answer on that. Yes, scan it again.
So... that is not what it means.
I mean, I put my name on everything and I don't know. I told you.
Alright, hold up. Everything is fixable. Yeah. You have a question?
Can I try to do it?
Sure, if you want. Hey guys, what type of creature am I? I'm a human, right? And are humans perfect? No. So this is like my one mistake for 2022, right? This is the only mistake I'll make, but it's my one. Hey, if you're talking, you're not helping. I will go make the copies you're supposed to have. I'll bring them to language arts because all of you are headed to language arts together, and I will give you the proper 524. Okay, you should be able to do everything that is on that homework, which is why John was like, what the heck is this? But your 524 should make sense. So we gotta head to language arts. I will go copy what you need. My bad. My one mistake for the year. Oh, you could have done that, John.
No, it's like find it for water.
Yeah, the solve for the certain variable.
Yeah.